All right, again, we're going to take a moment to review factoring polynomials. If you notice here, I've got 6 different examples, and then among those 6 examples, we're going to look at just the different ways that we can factor them, some things to look for to help us know whether or not we need to factor in whatever way possible. So first of all, I want to look at example number 1. This is, again, what we call an A equals 1 trinomial. So A equals 1 trinomial. And what that means for us is that we're going to create an X. So I'm going to create an X to help me factor. Again, my number at the back is my C. So I'm going to take that C number right here, and I'm going to put it here. So it's going to multiply to make 20. And then my B number is going to go to the bottom. So I need something that multiplies to make 20 and adds up to make 9. So I need 2 factors that do that. One of the things I want to pay attention to is that all 3 terms in my trinomial are positive. Because all 3 are positive, that tells me that both of my factors are going to be positive. So now I just simply need to narrow it down. So I need to think, what can I multiply together to make 20? And then of that, which 2 make 9? So I've got 1 and 20. I've got 2 times 10. And then I have 4 times 5. Well, of those, the only 2 that add up to 9 are 4 and 5. So my factored trinomial would be x plus 4 and x plus 5. And again, I can write those in either order. And again, this is just in general if we're asked to factor, or later when we're asked to solve a quadratic. Remember, this is one of the ways that we can solve is by factoring. And then we would set each of those factors equal to 0. And so we would say x plus 5 equals 0. And I would subtract 5 from both sides, so x equals negative 5. So one of my zeros could be negative 5. And then I would say x plus 4 equals 0, subtract 4 from both sides, and x also equals a negative 4. So I could also find my zeros using this exact same method. So factoring not only helps me in when I'm factoring, but it can also help me find the zeros of a function. All right, moving on to our second polynomial. Again, I have an A equals 1 trinomial. So again, I'm going to create the X. This time, I'm going to have it multiply, and my C value this time is a negative 30. And then my B value is going to be a minus or a negative 13. All right, so what that tells me is when that last number is negative, it tells me that one of my factors is going to be positive and one is going to be negative, because a negative times a positive makes a negative. So I need 2 numbers that with different symbols are going to add up to 13, or in this case, really what I'm saying is they're going to subtract and make 13. So if I go to the factors of 30, I would say 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Well, of those, the only 2 that subtract and make 13 are 15 and 2. So then I know that I need to use 2 and 15, and now the second part becomes what number needs to be negative and what number positive. Well, since my bottom number is negative, I want the larger of the 2 to be negative. So it should be x plus 2 and x minus 15. So again, my factored group would be x plus 2 in parentheses and x minus 15. If I've got my TI Inspire calculator, or I'm on desmos.com/calculator, I can type in x squared minus 13x minus 30 and then type in what I think is the answer. And if it's true, it should be 2 graphs that overlap. They should perfectly match each other. If I'm wrong, it'll be off a little bit. I'll see 2 separate in different locations, 2 different quadratics. And again, I can find those zeros by taking x plus 2 equals 0, subtracting 2, so x equals a negative 2. And then x plus 15 equals 0, subtract 15 from both sides. So then x equals a negative 15. So again, I can use that to find a couple of different things. So factoring comes in handy a couple of different ways. All right, looking at number 3, I have something a little bit different. I don't have a trinomial, I have a binomial. And in that binomial that I have, I notice that there's a subtraction symbol between them. And so when I see a subtraction symbol in a binomial and they're asking me to factor, I want to check the numbers. I want to look and see, does 36, is it a perfect square? And then I want to ask myself, is 81 a perfect square? If the answer to that is yes, then I'm going to set up what we call a difference of squares. So I'm going to set up 2 binomials, one with a plus sign in the middle and one with a minus. And then I'm going to square root the 36 and get 6. I'm going to square root x squared and get x, and I'm going to put it in each side. And then the square root of 81 is 9, so I'm going to put a 9 on each side. And that would be my factored form. So square root the first term, square root the last term, and then put that solution in each binomial, one with plus and one with minus, and that's what cancels out that middle number, but also gives us our perfect squares. All right, and again, if I were to solve that, I would say 6x plus 9 equals 0. I would subtract 9 from both sides, so 6x equals a negative 9 divided by 6. And so then x equals a negative 3 over 2. Then I would do the same thing over here, 6x minus 9. I would add 9 to both sides. So now 6x equals 9 divided by 6. So x equals 3 over 2. So again, I could get my zeros just by solving, by setting both factors equal to 0. All right. Then my fourth one again is an a equals 1 trinomial, so I'm going to set up my x. I'm going to put my multiply by 36 here. I'm going to put my plus 12 at the bottom. Again, my entire trinomial is positive, so I know both of those are going to be plus. If the back is plus and the middle is negative, that means they're both going to be minus. If the back is a minus, then that means we're going to have one of each. So here I've got 2 that are going to be positive, and they need to add up to 12 and multiply to 36. Well, I've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then I have 6 and 6. Well, the only 2 that add up to 12 are 6 and 6. So my answer would be x plus 6, and then the correct way to write it would be with the exponent 2 at the top, which means x plus 6 times x plus 6, or x plus 6 all squared. And that's how it's going to show up on the test. Again, I can set that equal to 0 because it's the same. That means that we're only going to have 1 0, so that means the vertex is going to touch the x-axis. I would subtract 6 from both sides, so x equals a negative 6. And again, I can graph the original, graph my solution, and they should match up. If I look at numbers 5 and 6, they look very much like 1, 2, and 4, but there's a subtle difference. We have a number in front of the x squared. So we're going to create the x like we've always done anytime we have a trinomial that we're factoring. But in this case, I need to multiply the a number and the c number. So I'm going to multiply 9 and negative 2. So 9 times a negative 2 is a negative 18. And then I need it to add up to 3. All right, again, if that last number is negative, that tells me one's going to be plus and one's going to be minus. In this case, because the bottom is plus 3, my bigger number needs to go with plus and the smaller number needs to go with minus. So now I just need to think about 18, and I need to think about 2 factors that have a difference of 3. So if I go to 18, I've got 1 and 18. I've got 2 times 9 and 3 times 6. Well, if I subtract those, the only one that has a difference of 3 would be 3 and 6. So again, the 6 would go with the plus, the 3 would go with the minus. So I would write x plus 6 times x minus 3. But I can't finish here. This is that one where we have to go another step because of the 9 in front of the x squared. So what I need to do is divide both of these by 9. Now, the rule tells us that if it doesn't divide or simplify, or even if it does simplify, if it doesn't divide evenly, we're going to have something that we're going to have to move from the back or the bottom to the front. So when I look here at 6 divided by 9, that becomes 2 over 3. And then that 3 needs to move up in front of the x. So it becomes 3x plus 2. Again, the same thing here. 3 and 9 is going to simplify to 1 and 3. So then this becomes 3x minus 1. So 3x plus 2, 3x minus 1. And again, to find the solutions, we would say 3x plus 2 equals 0. Subtract 2 from both sides. Again, I'm just solving for x by getting everything away from x. So 3x equals a negative 2, divide by 3. So x would be a negative 2/3. That's one solution. Then I would go back and say, okay, 3x minus 1 equals 0. Add 1 to both sides. So 3x equals 1, divide by 3. So x equals 1/3. So my two solutions would be negative 2/3 and a positive 1/3. All right, go ahead and pause the video. I want you to try to do what I just did on number 5, to do that with number 6. And then I'll come back in just a second and I'll make sure that you have the right answer. Okay, hopefully you got the video paused. Now we're going to pick up where we left off. So in this case, we're going to multiply 6 and 15. 6 times 15 is a positive 90. And then we need it to add to a positive 23. Again, all three numbers in my trinomial are positive, so I know that both of my factors are going to be positive. So I need two numbers that multiply to make 90 and add up to 23. So when I get 90, 90 could be 1 times 90. It could be 2 times 45. It could be 3 times 30. It could be 5 and 18. Could be 6 and 15. Then it could be 9 and 10. All right, so when I add those up, 9 times 9 and 10 is 19, 6 and 15 is 21, 5 and 18 is 23. So I want to take 5 and I want to take 18. So I'm going to say x plus 5, and then x plus 18. And again, I'm going to divide by the a value. Well, in this case, a was 6. So I'm going to divide both sides by 6. Well, over here on the left, 6 does not divide evenly into 5, and it cannot simplify. So I bring the 6 to the front. That becomes 6x plus 5. Over here on the right, 18 divided by 6 does work evenly into 3. So my two factors are 6x plus 5 and x plus 3. Again, as before, I could set those equal to 0. I would subtract 5 from both sides. So 6x equals a negative 5. Divide both sides by 6. X equals a negative 5/6. All right, going to the last factor here, we have x plus 3 equals 0. I would take away 3 from both sides. So then x equals a negative 3. So again, that's how we factor. And then the second step I showed you on each one was just how to find the zeros in case those were trinomials that we're trying to find the solution or the roots or the zeros to those. I hope this helps. If you have any questions, please let us know.